Hey guys, so this video is all about the chain rule. So we just went over a little bit of it in class together, but to help you guys get some notes down and to really get a little bit more understanding, I'm going to go through some in the video right now for you. So the first thing we're going to talk about is finding the derivative of the composition of two functions. That's what the chain rule actually is. So a composition means one function inside of another. So for example, we could have something like h of x equals f of g of x. All right, that is our original function. So if we were to take the derivative of that, h prime of x, we're going to first take the derivative of the outside function and leave the inside function alone. So f prime of g of x. And then we need to multiply by the derivative of the inside, so g prime of x. This g prime of x part, this is what we refer to as the chain. All right, so we are going to take the derivative of the outside and leave the inside alone. Then we're going to take the derivative of the inside. All right, so let's see what this actually means. So taking a look at number 1, we've got f of x equals the quantity of x squared plus 3x all raised to the 4th power. So if I covered up this part here, hopefully you guys can see that it's something to the 4th power. So that outside piece is the 4th power, and the inside piece is x squared plus 3x. So what I'm going to do is I'm going to first rewrite my function so that I can see the two separate pieces. So when I rewrite this, and this is why the colors are so nice, guys, f of x is going to equal something to the 4th power. And that something is x squared plus 3x. So I can clearly see my two different functions. Then the next thing I'm going to do is actually apply the chain rule. So step 2 is now to take the derivative using the chain rule, which means f prime of x equals, I need to take the derivative of the outside function. Well, if I have something raised to the 4th power, that's just a nice power rule. I'm going to drop the 4, so it becomes 4 times whatever raised to the 3rd power, because I have to subtract 1. That inside piece stays exactly the same. It's x squared plus 3x. So again, if this wasn't even here, if this was just an x, the derivative would be drop the 4 and subtract 1, so 4x to the 3rd. Except it's not x anymore, it's x squared plus 3x. So now the chain rule comes into play, and I'm going to have to actually multiply by the derivative of the inside. Well, x squared plus 3x, that derivative is 2x plus 3. That's again just some simple power rule. And that's actually just your answer. We're not going to have you simplify anything else from there for right now. All right, that would be your answer. Let's take a look at number 2. So for number 2, we're going to again rewrite it. So instead of y equals the square root of 4x squared plus 5, hopefully you can look at that and you can see that if I take the square root of something, it's the same as raising it to the 1/2 power. And my inside function is this 4x squared plus 5. So when we look, we've got something to the 1/2 power. That 1/2 power is what's on the outside. So when I do my second step, which is to actually use the chain rule, I'm going to do y prime equals, I'm going to drop my 1/2 and leave the inside alone, remember. So 4x squared plus 5. And I'm going to subtract 1 from my exponent. So 1/2 minus 1 gives me a negative 1/2. Then I have to remember to actually multiply by the chain. So 4x squared plus 5, the derivative of that That's just some simple power rule. That's 8x. Now this one I am going to simplify a little bit just to show you guys that it does actually look a little bit nicer when we simplify it. So what we can do here is we know that this 1/2 times 8x is actually going to give me a 4x. And a negative exponent, I'm going to drop it like it's hot. So I get my 4x squared plus 5 on the bottom. And I could write it to the 1/2 power, or I could actually just write it as a square root. And since my original function had a square root, I'm thinking that my answer probably should as well. So this is what my final answer is going to look like for number 2. All right. Question number 3 looks a little bit different. So when we look at this problem here, we need to look at a couple of things. For this first part here, 3 times the square root of 6x plus 7, hopefully you guys can look at that and you can see we do in fact need the chain rule for that one, because the square root has something inside of it. So we have 2 functions there. For this second piece though, 4x to the 5th, this should be easy. This is just some normal power rule. There's no chain rule involved in this one. So don't get confused and think that now we need chain rule for absolutely everything. Okay? So let's first rewrite. So we're going to get g of t. This is still just our original function. And it's 3 times something to the 1/2 power. And we know that that something is 6x plus 7. And then we've got plus 4x to the 5th. Now notice I didn't take a derivative yet. No dropping exponents and subtracting 1 yet. This is my rewriting stage. This is the exact same function as my original. I just wrote it in a different way. Now I'm going to go ahead and actually take the derivative. So g prime of t is going to equal, I'm going to need some power rule and chain rule here. So I'm going to drop the 1/2. That becomes 3/2. And subtract 1. That becomes a negative 1/2. And my inside piece stays the same, 6x plus 7. Then I'm going to multiply by the derivative of the inside. I need my chain piece. So the derivative of 6x plus 7 is just 6. Then I'm going to go to my 4x to the 5th. That's just some nice simple power rule. 4 times 5 is 20. And then I get x to the 4th because I need to subtract 1. Now when I simplify this one, g prime of t is going to equal, if I do 3/2 times 6, I know that I'm going to get 18 divided by 2, which is 9, over, this drops to the bottom and becomes a square root of 6x plus 7. And then I have plus 20x to the 4th. Oh, and actually I just realized that all of those x's should be t's. I wrote myself a note to fix that before I started this problem, and I didn't. So that's my bad, you guys. If we could go through and change those really quick. This should be a t, and this should be a t. So this is t. And this one is a t. Sorry about that. If you guys can go through and switch those for me, that would be great. Because we said our function is g of t, which means our function needs to be in terms of t. So that should be 9 over the square root of 6t plus 7 plus 20t to the 4th. And that is our final answer for that one. All right. We are actually going to do number 4 in class together, just to make sure that we're all kind of on the same page. And we're also going to do these table ones in class, except for I'm going to do the first one and the third one, just to kind of give us an idea. So we've got f, f prime, g, and g prime, and we're going to use the table to evaluate the given derivatives. So we were given that h of x is equal to f of x plus g of x. Well, when we look at this, we're just adding two functions together. And we're trying to find h prime of 2. So before I do that, I actually want to find h prime of x. So if I want to take the derivative of two functions being added together, I can actually just take their derivatives like normal. So it would just be f prime of x plus g prime of x. There's no real trick to that one. Now the trick comes when I have to actually do h prime of 2. So I'm going to need to do f prime of 2 plus g prime of 2. So when I look at my table, f prime of 2, this is my f prime. Here's the value of x equals 2. So f prime of 2 is really just 1/2. And then g prime of 2, so here's g prime. Here's the x value that's 2, so that's plus 1/2. So h prime of 2 is really just 1/2 plus 1, which is 3/2. Okay, so that one was pretty easy. We didn't need chain rule for that. But let's look at number 7. Number 7, we have a composition of functions. So we have h of x equals f of g of x. So when we take the derivative of h of x, we have to take the derivative of the outside, which is going to be f prime, and leave the inside alone, so g of x, and then times the chain, which is g prime of x. So now when we look at our table, we're going to have to look at things a little differently. If I want to find h prime of 2, I'm going to first have to do f prime of g of 2 times g prime of 2. Well, now I need to look at what g of 2 is. This isn't g prime, it's g of 2. So here's my function for g of x. And when x is 2, g of x is also 2, which means I'm going to do f prime of 2. Messed up my color. Oops. Times g prime of 2. So f prime of 2, well, we did that already. That was our 1/2. And then we have times g prime of 2, which is, here's g prime, here's 2. Oh, so that's a 1. And so then we have that h prime of 2 is equal to 1/2. So for that one, we did have to actually, oh, you guys can't see that, sorry. We did have to actually incorporate some chain rule there. So we just have to make sure we're looking at the right pieces on our table. But hopefully that makes sense. We've got 6 and 8 that we can talk about together. And we'll get together and do some practice now. All right? Bye.